In 1969, the United States and the Soviet Union were pouring billions of dollars into their space programs. Meanwhile, India's newly established space agency started with virtually no financial backing. Under the direction of physicist Dr. Vikram Sarabhai, they adopted a strictly practical philosophy. Every launch had to directly serve a developing nation's real-world needs, from weather forecasting to communications. Engineers literally transported their very first rocket components through a small fishing village on the back of a bicycle. By 1975, they built their first satellite, Aryabhata, though they still had to rely on a Soviet rocket to actually get it into orbit. With no access to the massive budgets of the Cold War giants, the agency turned inward. They began building an infrastructure designed for necessity, prioritizing a strategy that traded raw power for precision. Escaping Earth's gravity is incredibly expensive. Traditional spaceflight demands massive amounts of volatile fuel, which inflates the budget of every single mission. To bypass this financial barrier, the space agency mastered a philosophy known as frugal engineering, or jugaad, the practice of maximizing minimal resources. Instead of burning massive amounts of fuel, engineers place a spacecraft into expanding elliptical orbits, using Earth's gravity to build momentum. Once peak velocity is reached, they fire small thrusters to break out of the final loop, slingshotting the payload directly toward deep space. In 2013, the Mars orbiter mission utilized these gravity assist loops to reach the red planet. India became the first nation to achieve a successful Mars arrival on their very first attempt. They pulled it off for roughly $74 million. That is a mere fraction of the cost of standard Western missions, and famously cheaper than the budget of the Hollywood movie Interstellar. By replacing brute force rocket burns with calculated orbital mechanics, they engineered a highly efficient method for deep space exploration. With their orbital mechanics proven, the physical scale of their missions expanded. In 2008, scientists prepared the Chandrayaan-1 lunar probe. That probe carried an instrument that officially detected water molecules on the lunar surface, a discovery that immediately altered global plans for future moon colonization. Their precision quickly translated into commercial satellite deployment. Foreign governments and private companies began booking space on the trusted PSLV rocket. In a single mission in 2017, that rocket deployed a world record 104 satellites into orbit simultaneously. The momentum hit a severe roadblock in 2019. The last-minute crash of the Chandrayaan-2 lander served as a harsh reminder of the inherent catastrophic risks involved in leaving Earth. Their approach. In 2023, they launched Chandrayaan-3, specifically targeting the treacherous terrain of the Moon's south pole. When the lander finally touched down, India proudly became the first nation to secure the ice-rich lunar south. Inside mission control, decades of strict budgetary constraints and complex engineering finally culminated in a massive wave of human validation. Through this rapid series of milestones, the agency completely shed its underdog status, solidifying its position as a primary global destination for high-stakes precision engineering. These cascading technical triumphs have sparked a massive cultural phenomenon, capturing the imagination of millions of young people across the globe. Aerospace engineers and former leaders, like Dr. APJ Abdul Kalam, have been elevated to the status of national heroes. Riding this cultural momentum, they launched Aditya L1, a dedicated solar observatory positioned to continuously monitor space weather and solar activity. Next on the immediate roadmap is the Gaganyaan mission. This will be India's first indigenous manned spaceflight, designed to send astronauts into low Earth orbit and bring them back safely. Beyond that, they are also drafting detailed blueprints for the construction of their very own independent space station high in Earth's orbit. Their status as a peer to legacy agencies is further cemented by ISRO, an upcoming high-end radar satellite mission conducted in direct partnership with NASA to map the globe's ecosystems. From the dirt roads of Thumba to the lunar South Pole, the agency has demonstrated that focused national purpose can compete with the largest treasuries. As they target the deeper solar system, they have established a distinct blueprint for reaching the stars.